Hey everyone, welcome to my channel. In this video, we'll be talking about indexes in the Pandas data frame or in series, and we'll also look at some of the associated functions with indexes and what it means, what's its analogous it means in a dictionary or in Python or native Python data structures. So this video is still in continuation to my previous video, but so far we have been using the other CSV file, which was from electronics card transaction, something like that. But now I'm going to show you another sample method, another method to find out the sample CSV files from the internet. So one such simple method is you can go to the Google and type in data.csv. It will give you a bunch of websites. Now the top one, if you look at, it's of a Kaggle, www.kaggle.com website, and if you look at that, it will give us the list of open source data sets which are available for you to use. There are a bunch of files which people have either collated or have sourced it from somewhere else, and they have posted it for us to use it open source. Now, for the sake of for this video, I'll be using a small sized data site CSV file, which is of a married at first sight. You can take a look at other data sources as well, and you may choose to work on any of the CSV files. So for now, I'll be using this married at first sight CSV file because it's hardly of 2 KBs, and I've already downloaded it, and that's the one I'll be going to use to go through this tutorial. So as a first step, I'm going to use the MAF SDC file. I've already downloaded it, and let me show you what DF does it contains. So it is basically a CSV file which contains information such as couple, season, location, name, age, gender, occupation, and whatnot. So these are basically the columns which are present in the data. And let me check the size of the data. So we have df.shape as 68 rows. So it has 68 rows and 17 columns. I need not pass any column header options while reading the CSV file. Now, if you look at the bold lines, this first row is basically the columns, which we have already explained earlier, and how to access each of the columns and rows using log and ilog functions. If you have not checked it out, go back and look at that video. Now the next thing here is what are indexes. So as you can see, there is no such thing which is present over here. Indexes by default run out from 0 to n the shape, which is the number of shape 0, which is the number of rows in the data, and they are named numerically and in increasing fashion. So here in the labels for indexes is 0, 1, 2, and 3. So unless you specify any index column as such in the data frame while you are reading a CSV file or any such file using Pandas library, yeah, the indexes is basically the numerical increase is just another column with increasing number of increasing numbers labeled as an index for that data frame. Now the similar situation in if you look at in a dictionary, in a Python dictionary, you can for the example, I have prepared a dictionary where there are 3 keys: date, models, and flags. So dates basically is containing a start date from 2017 first to 2017 L, which is 12 months of data. And if you look at what dates contains, so it's basically the first of every month as a date time object, and that is contained in the dates variable. And the frequency is basically ms. There are a bunch of other frequency options that are available in the pd.date range function, which we'll cover sometime later, either in this video or some other video. But for now, you have to assume that pd.date range basically provides a list of date time 64 ns objects from the start date to end date with a given frequency. Now once we have that, I have also prepared another list of 12 numericals as models, and then flag as basically the booleans with 12 values as it is. So if you look at the sample, this is what my sample dictionary looks like. Now if you want to convert it to a data frame, then the columns would be the keys and the values would be the rows in the data frame. Now let's rename it to new data frame. Here here we have our new data frame dot shape. If you look at it, it's basically 12 rows and 13 columns. Awesome. Now what we need to check is how to set the indexes. So indexes, we still because we have not set any index while creating the data frame from the dictionary, we still have the indexes labeled by default by the pandas library, which is in numerical increasing, is monotonically increasing in number from 0 to 11 onwards, which is the number of rows in the data. Now you can also set a specific column as an index. Now how to do that is basically just type set index and then pass it the name of the column that you want to make it as an index. Let's say I want to make the date column as an index for within the new data frame. So you type in the new df.setIndex date, and there we go. So we have the date column labeled as an index. So now each of the rows is the label of each of the row is basically the corresponding date, and we have the columns only as models and flag. But if you go to the next cell and if you just type new df, you will see that date is still over there. So this means that the changes that has been introduced after running this command of set index date, that change is not being reflected to the data frame. So in order to do that, there are two methods. Either you can assign it to the variable original to itself, or you can use another method or another parameter in the set index function itself, which is of in place equals true. So what it does is instead of creating a copy of the original data frame, it just make the changes in the data frame at it in place and does not return anything to you. So if you do the in place equals true, and then if you print out the new df, it basically has already made the change, and you need not assign it to the back to the original data frame. So this way you have the date as your set being set as an index, and you have models and flag as columns. Now if you want to look at the data corresponding to a specific row, so let's say I want to check at this row, the data present at 2017 3 and first. So if you look at that, you can see there are two columns, model 3 and flag equals true. So this way you can look at the you can basically traverse through the entire data frame based on log and ilog methods. But now earlier we were using the numerical values as the labels while indexing the rows, but now we can use the whatever column that we have set as an index and the values present in that column as a reference to pull out any specific rows, or even a given range of rows as well is possible with this. So let's say I want to go from 2017 to, let's say, 8 onwards. So what, in order to do that, I just have to pass it this, and it will give me all of the values which are present from 2017 March to 2017 August onwards, both inclusive. So this is the method to use indexes, and it provides a handy way to traverse through any data frame in general. So now once you have set a index, a specific column as an index in data frame, we can also reset it using new df.reset index. And if you pass in that, you can see that the data frame is reset back to the original data frame where the date is represented now as a column. Again, you can also use, I think there's an in place method. So it provides an in-place attribute and level drop. So level is basically for the if you have a multi-level index, which we can talk about later part. But for now, you just have to assume that there is only one level of index that is present over here. So if you do the in-place equals true, you can get the original data frame back. Okay, cool. So this was something about data frames, and likewise we have our data frame here of MAFS. So you can see there are a couple of columns which are present over here. Now as I said, here also if you just read by default without providing any options in while you are reading a Pandas CSV file, then it will basically set a default column on its own as an index, and it will not assign any specific column as an index. And if later if you want to change any column or set any column as an index, you have to manually do that. So for example, couple, or if you want, let's say want to specify the gender as a as a column for this data frame, you have to just pass in gender comma in place equals true, and it will basically set the data frame with the gender column as an index. So this is one way of setting the index, but what we can do here is, if we already know the list of columns that are present in our data frame, then we can provide an index. Wait a second. Index call equals gender as an as another parameter while we are reading the pandas data frame itself. So this way it will create the gender column as an index, and if you look at the head of the data, you can see that the column gender is being labeled as an index for this data frame. Now there are other things that you can do here. You can, for the moment, we are not going to reset. We're not going to set anything as an index. We are just going to look at the data. The other thing that you can do with it is you can maybe sort your data based on corresponding index. So right now we have the index sorted as 0, 1, 2, and 3. So it's already sorted. So then there won't be any effect if you run df.sort index. So it won't change anything to you because it's already sorted. But if, let's say, we set status as our index, so df dot set index, sorry, let's say we have set as an index, as status as an index. Now if you look at the head of the data, you can see that there are a couple of options such as married, divorced. Now if you want to sort the data, then you can do it based on another function which is provided by the pandas library, which is an awesome library, in fact. So you can see ascending is another parameter that is provided by the sort index function. You can set df.sort index ascending equals to, it will basically sort in the alphabetical order. So D comes before M. So we have divorced as the first key, and then some after later, I think here onwards, you have the married columns. So this way you can sort the indices. It comes handy when you are working on a larger data frame. So this way you can sort out your indexes and or maybe change to another column as well. Now just wanted to highlight one more thing here is, if you are working with the time series data, then it's usually very handy to label your date column as an index over for your data frame. That basically saves a lot of time while you are traversing or while you are creating samples like quarterly or yearly or monthly samples. So this way it basically helps you, the setting indexes basically helps you in restructuring your data, or even grouping the data based on different frequency that you are expected to perform. So for this video, that's all I have, and I'll be making another video where I'll be covering more complex operations which are performed or are provided by the pandas library. So that's all for now, folks. If you have liked this video so far, if you have watched it so far, do check out my other videos and like and share and subscribe to my channel.